This video is brought to you by leXsolar, understanding new energies with teaching systems and training systems for school, technical training and further training, and the YouTube channel Innovative Technology and Energy Transition. Wind turbines are arguably the most important renewable energy source in Germany. In 2020, 128 terawatt-hours of wind power was generated, which is 25.6% of the total electricity generation. This was even the first time that wind power accounted for the largest share, replacing coal as the most important energy source. At the same time, there are still many critics. The biggest criticism of wind energy is its strong dependence on weather, which is not always windy in Germany, resulting in a great burden on the power grids, as wind turbines are increasingly built in the windier north. To what extent this criticism is justified and what you can do about it, you will know at the end of this video. You will also learn how a wind turbine is built and how it works. First, let's take a look at the structure of a wind power plant. The biggest part of the wind power plant is the wind turbine itself. It usually consists of a hub and 3 rotor blades. In rare cases, only 2 rotor blades are used. However, the design with 3 rotor blades has prevailed due to the efficiency and the lower mechanical load for the wind turbine. The rotor blades converts the translational kinetic energy in the wind into rotational kinetic energy in the wind turbine itself. The kinetic energy is then converted into electrical energy using a generator. Both asynchronous and synchronous generators are used here. In most cases, a gearbox is also used here to increase the efficiency of the overall system and to achieve the ideal speed range of the wind turbine. In the past, turbines with asynchronous generators were sometimes connected directly to the grid. Nowadays, the generators are usually connected to the grid via power converters for much more efficient operation. For this purpose, a rectifier and an inverter are usually used, which makes it possible to adapt the speed range of the wind turbine to the wind speed and thus significantly increase the efficiency. For the functionality of these converters, this entire system sits on the top of a tower, which in turn is mounted on a stable foundation. In the following, let's take a closer look at how the wind turbine works. To convert the wind energy into rotation of the rotor blades, the blades are shaped like wings. The same effect is used to make airplanes fly. Aerofoils are shaped so that the air flowing past them is slower under the aerofoil than above it. This creates positive pressure below the airfoil and negative pressure above. The positive overpressure pushes the wing upwards and the underpressure also pulls the wing upwards. The resulting force thus acts upwards. In the case of rotor blades, this force acts in the direction of rotation in each case and generates a torque that drives the wind turbine. The resulting forces can become extremely large. This can go so far that the wind turbine can destroy itself during a storm. A video of a wind turbine from Denmark where exactly this happened, I'll link you in the video description. To prevent this, the wind turbine must be regulated when the wind strength increases. There are different ways to do this, but one of them has become accepted nowadays. Here, the control of the wind turbine consists of 3 subsystems. First, the position of the rotor blades in the wind is changed by rotating the rotor blades in order not to extract too much power from the wind at higher wind speeds, thus protecting the turbine from damage. The second subsystem drags the entire turbine to the wind direction so that the wind turbine always aligns itself perpendicular to the wind speed, providing maximum power. Another controller influences the generator's power electronics so that torque and speed are set ideally and independently of the frequency of the power grid to maximize the efficiency of the overall system. In addition to these 3 subsystems, most wind turbines have a mechanical brake for safety reasons, which can additionally slow down the wind turbine in case of emergency, for example if the other systems are defective. You can find more interesting videos like this here on the YouTube channel Innovative Technology and Energy Transition. You want to understand new energies or teach them to others with teaching systems and training systems for school, technical training and further training? Then check out the leXsolar homepage now.